Hi, I hope you guys are doing well. I wish I could be there. It's always easier to be there and help out, but I just can't be there this time. I have a child at home who is feeling under the weather, so I need to be home with Nathan. But hopefully this video will help you guys get started. All right. So what we're going to be learning about in this video is actually the distance sensor. Okay. And we use the sharp distance sensor. Let me go ahead and switch screens here. This is what it actually looks like. This is the sensor right here. Okay. It can read distances between 10 centimeters to 80 centimeters. Once you get closer than 10 centimeters, it doesn't work as well. The numbers start changing just a little bit. So let's go ahead, jump in. We're going to learn first how to wire it. Then we're going to take a look at how to code it. And then at the end, you're going to go ahead and get the challenge that you need to do. All right. So first, wiring. And I do have to ask you to make sure that you wire these carefully. Make sure you wire them into your Arduino and your breadboard carefully. You can fry them. You can cook them if you wire it wrong. And these are quite expensive. These are about 30 bucks a piece. So I just ask that you use your mind, use your head. Be careful as you do it. Make sure you know what you're doing while you're doing it, so you don't fry these little infrared sensors. Okay. Now, basically how they work is one of these guys sends out a signal. If there's something in front of it, it bounces back. It gets received by the other guy. And based on how long that took, it can figure out how far something is away from it. All right. So let's go ahead. Let's take a look at these wires down here. I did extend a lot of them. Went through and I tested all of them. They all work, which is great. I extended them. When they come, they don't have the wires that are easy to push into your breadboard on them. So I went ahead and I soldered some wires on. I also used some shrink wrap to go ahead and coat them to make sure that they hold firm. Don't pull too hard on them, but they should be pretty good to go. All right. Well, this red wire here, these guys actually take power. They need power to be able to run. So this guy right here, this needs to be plugged into the 5V port on your Arduino. And that just gives it that 5 volts just to be able to run. Now I plugged mine directly into the 5V, which is great. You could put a jumper wire to your breadboard. A lot of times it would go to the red rail with a little plus sign. That would be your 5-volt rail. And then you could have another wire from that goes to your sharp infrared distance sensor. But either way is fine, right? Now to this guy, same thing. That black one, that black is ground. And you can put it, once again, you can put it in your Arduino, or you could put it in your ground rail on your breadboard, and then have another wire going to your Arduino. That would work as well. Either one is fine, okay? Now, this is the important one right here. This is your signal wire. This is where the infrared sensor basically tells your Arduino how far away something is, okay? Now, in this case, you're going to put it into the analog 0, the A0 port. Now, keep in mind, a lot of the stuff that we've been using, pretty much everything we've been using the digital rail, the digital side, the side that goes from 0 to 13, the side that either has PWMs or reads zeros and ones. In this case, we don't want that. In this case, you want the analog side. So if you look at the side of your Arduino, it's on the same side that the 5 volts is on, but you have a few different ports, A0 through A5. And if you look on the side, it actually says analog in for those as well. That's where you want to put it. You want to plug it into A0. Okay? And then just another reminder, digital reads zeros to ones. That's just what they read. That's what you get from them, 0 to 1. Analog, that gives you a value between 0 and 1023. So it gives you some number in between there. All the way down to 0, all the way up is 1023. So that's a good thing to be able to see as well, just how analog and digital is different. All right? All right. Let's see here. I'm going to go ahead and grab my Arduino right here. Hopefully you can see that on the screen. I'm going to go up. That's just a basic sketch right there. Don't want that. I'm going to go File, Examples, Basics, Analog Read Serial. That's File, Example, Basics, Analog Read Serial. Now, hopefully that comes up. Yep, that comes up right here. I'm going to get rid of my previous one, and hopefully you guys can see that well. Make it a little bit bigger, even though that's all there is there to it. Okay? All right, well, let's take a look at this, all right? So this is all, grayed out. Your computer's not going to read anything. Anything /* to // it's not going to read. The 2 forward slashes, your computer doesn't care about that. It doesn't read at all. But then down here, void setup, curly bracket, it's going to do everything from this curly bracket to that curly bracket only one time. It's serial.begin 9600. All that is doing is setting up your serial monitor. It's making your Arduino able to communicate with your computer, able to run at the same speed as your computer. So that's the basics. That gets it running. All right. Now down here you have void loop. Now void loop runs over and over and over again. So anything from this curly bracket to that curly bracket. And notice I can click right on that curly bracket and on that curly bracket, and it will do whatever is on the inside of that guy right there. Okay, so void loop inside the curly brackets. All right, so what's it going to do? Int sensor value. Okay, so we just made an integer. We made a variable that's going to be an integer, 1, a 2, a 3, whatever. It's going to be a whole number, not a decimal, not a part of a number, but sensor value. This is just the name of it, okay? You could change that if you want to. You could change that variable to be whatever you want it to be, okay? Notice sensor lowercase, the V on value is uppercase. We used one before that was sensor val. So just recognize this one's a little bit different. They typed it in differently, but you could change this. You can make that anything you want it to be, okay? Equals. Now here's a new command. Here's a command that we haven't seen before. Analog read A0. A0's in the parentheses, and then a semicolon. Analog read is the new command that you haven't seen before. So now you guys have one more thing in your toolbox that you can use later on. And what that does, that analog read, it just takes a look at the A0 pin, and it's going to get a number. And we'll be able to see that number itself, okay? So it's just going to get a number, all right? Now, like I said, we want to be able to see the number. So down here, serial.println sensor value. So what it's going to do is serial.println, that's just going to take your serial monitor, this little magnifying glass right there, and it's just going to basically say, all right, sensor value is going to say whatever this was right here, it's going to go ahead and it's going to show it via your serial monitor. Okay? All right, this delay 1, that's just, give it a little time, a little stability, give it a second for it to actually take a reading. Now, you have to excuse me a second. I have to grab my cord and actually plug. I wired in the distance sensor. I did not hook up the cord to my computer, to my laptop. All right, so hopefully that did it, okay? I'm going to do this probably the wrong way first. I don't know if it, I didn't go to my port or anything, so we're going to see if it uploads right away, but I want to see if it will. I would probably go to tools first. So compiling, it's done compiling, so we know we got legitimate code. That's a good thing if you changed anything. Now we haven't changed anything yet. Just going to try and upload it. I'm expecting to get, oh shoot, it uploaded, unfortunately. I was expecting to get some orange stuff down here. When you get orange stuff down there, that basically usually just means that, you're on the wrong port, okay? I'm gonna go tools. I just want to double check. Yep, I got it right here. We know we're on the right port because it says Arduino Uno right in there, okay? So it found the port, it has it, we're good to go. Let's see if it's actually working now that we downloaded it into there. So I'm going to open up my serial monitor, okay? Put that in there. Hopefully you guys can see that right there, see it going fast enough. I'm running around 35s, seeing a few 40s in there, stuff like that. I'm going to go ahead and put my hand over it, and it's working. I'm seeing 300, okay? I'm going to start moving my hand closer and closer and closer to it. I'm seeing 400, 500. If I go closer, I'm seeing in the 600 range, okay? Now I'm going to get really close. I'm going to get under 10 centimeters. It starts falling again. It still's reading, but it just has a tough time under 10 centimeters. So we'll keep our stuff that we're reading from it. We'll just have to keep it more than 10 centimeters away. Getting pretty close, like 20 centimeters, I'm getting in the 600 range. If I'm back, probably, 200 centimeters away, I'm getting like 200 range, up even higher, getting hundreds, and nothing in front of it. It's just shooting off to the ceiling, which is more than 80 centimeters away. I'm getting in the 30s and 40s. So we do know that our sensor is working, and that's a good thing because I went through and I double checked them all and I made sure that all the sensors were working. So hopefully you can get that. Hopefully you can get that thing reading. Okay. All right. Let's see here as far as the challenge. All right. So what the challenge is I want you to have 4 lights on your breadboard. I want you to have your infrared distance sensor working. And basically, I want it no lights on. And then as your hand gets closer and closer and closer to the distance sensor, I want more lights to show up, more lights to turn on, okay? And just remember, what those numbers were. The numbers were actually going up the closer that we get to the actual distance sensor, okay? So 4 lights, something gets closer and closer and closer to your distance sensor, the more lights go on. So there's no lights, something starts approaching it, 1 light turns on, then 2 lights, then 3 lights. And when you're really close, like, 15 centimeters away or so, then you got all 4 lights on, okay? I'm going to give you a hint on here. We're going to take a look at a previous sketch or a previous program that we used already. I'm going to go File, Example, let's see here, Digital, and I want to say it's Digital Input Pull-Up, okay? I'm going to go ahead and open that just because we're not going to really use this one. We are going to use a piece of that code right there, okay? And that code is down here. I'll go ahead and highlight it. Hopefully you guys can see it okay, even if it's highlighted. All right. So we have if sensor val. Now keep in mind this says sensor val. When we were using the analog read serial, it was value. So they spelled that variable differently. You got to keep it the same. Okay. Is equal to high. Digital right 13 low. When it's equal to high, when we had the button in that state, it did everything in that curly Q right there. Remember the curly Qs, okay? Else, it did everything in that curly Q here, okay? Now keep in mind, you don't need the else statement. You could just do the if statement. You don't necessarily have to have the else statement, okay? I might get cut off pretty soon because I think this program only allows me to do 15 minutes of recording per time. But you could take this, change it. Now, this is equal, okay? Now remember, you could also have something like greater than or equal to. So let's see here, shift, greater. if whatever number you're getting here is greater